Hello my dear students, welcome back to chemistry class. Today, let us continue the lesson acids, bases and salts. Let us revise what we have learned in the previous class. We have learned acid-base indicators. Two types of indicators we learned, natural indicators and synthetic indicators. Natural indicators we have learned the examples, red cabbage leaves, turmeric, colored petals of some flowers such as hydrangea, petunia and geranium. Synthetic indicators, we have learned the examples, phenolphthalein and methyl orange. Then we learn olfactory indicators, where the indicators which show different smells in acids and bases. Example for that, onion, vanilla and clove oil. Then we learn how do the metallic oxides react with acids. We learn that metal oxides when react with acids will get salt and water. Example, copper oxide plus HCl, copper chloride and water. Then how do reactions of that means non-metallic oxides react with bases we learned. Base plus non-metallic oxides will get salt and water. Example, calcium hydroxide plus carbon dioxide gives calcium carbonate and water. Today we are going to learn what do all acids have in common and what do all bases have in common. So let us see what do all acids have in common. So all the acids have similar chemical properties. You have learnt already all the acids are sour to taste and they turns blue litmus red. So all the acids are having similar chemical properties. And all acids generate hydrogen gas on reacting with metals. When an acid react with a metal, we'll get salt and hydrogen gas. That means all the acids generate hydrogen gas on reacting with metals. That means hydrogen is common in all the acids. Now let us see an activity to investigate whether all compounds containing hydrogen are acidic. We have seen now all the acids are having hydrogen. Now we are going to see whether all the substances, all the compounds which contain hydrogen are acidic or not. So here is an activity. Take solutions of glucose, alcohol, hydrochloric acid, sulfuric acid, etc. All these contain hydrogen. Now let us see how the apparatus is arranged. Fix two nails on a cork. Here you can see on a cork we have fixed two nails. And fix two nails on a cork and place the cork in 100 ml beaker. We have placed this cork in 100. This is a 100 ml beaker. In 100 ml beaker we have placed this cork and two iron nails are fixed on this. Connect the nails to the two terminals of a 6 volt battery through a bulb and a switch. So these nails we have connected to a 6 volt battery through a bulb and a switch. So this is the connection. This is the arrangement of the apparatus. Now pour some, so which are solutions we have taken? Glucose, alcohol, hydrochloric acid, sulfuric acid. Now pour some dilute hydrochloric acid in the beaker and switch on the current. So here pouring the hydrochloric acid here, switch on the current. We have to observe whether the bulb glows or not. Then pour the sulfuric acid and do the experiment the same way. There also we have to observe whether bulb glows or not. Now repeat the experiment separately with glucose and alcohol solutions also. Next what we have to pour? We have to pour the alcohol solution, see whether the bulb glows or not. Next we have to pour the alcohol solution and see. So we have HCl, pour the HCl and do the experiment. Next separately we have to do the experiment by pouring sulfuric acid. Next we have to do the experiment repeat the experiment by pouring glucose solution. Next by alcohol solution. All these cases we have to observe whether the bulb glows or not. So we have to see whether in all these cases bulb glows or not. So let us see the observation. So when you taken acids in the solution, we can see the bulb glows. Hydrochloric acid is taken or sulfuric acid is taken in the solution, the bulb glows. But if you are taken, when we have taken the alcohol or glucose in the solution in the beaker, we can't see the bulb glows. That means bulb doesn't glow when alcohol or glucose is taken. Even though this alcohol and glucose contain hydrogen atom, bulb doesn't glow. What does it mean? The substance which contain all the substances which contain hydrogen atoms, the bulb doesn't glow here. So why do the bulb glows? Bulb glows because acids conducts the electricity. When acids have taken here, bulb glows. That means the acids conduct the electricity here. Why when glucose and alcohol is taken, solutions are taken, why the bulb doesn't glow? Because as this glucose solution and alcohol solutions do not conduct the electricity. Now, what is the reason these acids conduct electricity? Let us see. So glowing of the bulb indicates that there is a flow of electric current through the solution. The electric current is carried through the solution by ions. So why the acids are conducting electricity? Because there is ionization takes place there. Ions are produced. Due to the presence of these ions only, acids are conducting electricity. But in the case of alcohols and glucose, even though they contain hydrogen atoms, there is no ionization. So let us see how the ions are produced in acids. So HCl, hydrochloric acid, it ionizes in water as H plus ions and Cl minus ions. So cation is H plus, hydrogen ions, and chloride is the anion. HNO3, nitric acid, ionizes as H plus and NO3 minus ions, hydrogen and nitrate ions. H2SO4, sulfuric acid, ionizes as H plus and SO4 2 minus ions, hydrogen and sulfate ions. This is the ethanoic acid or acetic acid. How does it ionize? It ionizes as H plus and CH3COO minus ions. That means hydrogen ions and acetate ions. So, if you can see in all these cases, which ion is produced in common? H plus ions. That's the reason these are acids. So, we can conclude that acid produce hydrogen ions or H plus ions. Aqua means aqueous solution, solution in water. In solution, which are responsible for their acidic properties. So, what is responsible for the acidic property of acids? This H plus ions produced in the solution. All the acids produce H plus ions in solution. These H plus ions are responsible for the acidic properties of these acids. And the case of glucose and alcohol, glucose formula is C6H12O6. Hydrogen atoms are there. In alcohol also, ethanol, methanol, propanol, all these there is presence of hydrogen atoms. But they do not ionize to form the H plus ions. That's the reason they do not conduct electricity. As they are not producing H plus ions in solution, they are not acids. That means all the substances, all the compounds which contain hydrogen atoms are not acidic. Then which are the compounds are acidic? Only the compounds which ionizes in solution to form the H plus ions, which produces H plus ions in solution, they are acidic. So what are acids? Acids are the substances which produces H plus ions in solutions. Now let us see, what do all bases have in common? So we can repeat the same activity what we have done with the acids and glucose, alcohol, all these. Using alkalis, such as, what are alkalis? Bases that dissolve in water are called alkalis, such as sodium hydroxide, calcium hydroxide, potassium hydroxide, etc. So what we can see? We can see the bulb glows. What is the reason for that? These bases are conducting electricity. Why do these bases conduct electricity? Because they ionize in water. So let us see how the bases ionize in water. Sodium hydroxide, NaOH, it ionizes as Na plus cation and OH minus anion. CaOH twice, calcium hydroxide base ionizes as Ca2 plus cation and OH minus anion. Similar way, KOH ionizes are potassium hydroxide or KOH ionizes as K plus cation and OH minus anions. So in all these cases you can see the common ion formed is OH minus. So we can conclude that bases are the substances which contain one or more hydroxyl group in their molecule and can release them in water as OH minus ions. So all the bases are having hydroxyl group. What is hydroxyl group? OH group. And they releases OH minus ions in solution. So the substances which releases OH minus ions in solution, they are called bases. These OH minus ions are responsible for the property of the bases. So today we have learned what do all acids have in common. All the acids have H plus ions in common. What do all bases have in common? All the bases have OH minus ions in common. Hope you understood today's class. Thank you, children.